In this section, we continue with quadratics, except now we're going to add a little bit more to it. Now, we did this earlier in the course when we were working with rationals. Remember, we did a whole bunch of simplifying rationals and factoring and all that. And then at some point, an equal sign appeared, and we moved from rational expressions to rational equations. Well, the same thing's happening here with quadratics. We worked a little bit with quadratic expressions and quadratic functions. We graphed parabolas, but now we're actually going to solve a quadratic equation. So you notice down here, it says a quadratic equation has the form of ax squared plus bx plus c is equal to 0. And again, we put the same reminders that a cannot be 0, because if a is 0, then that whole ax squared term disappears, and without an x squared term, it's not a quadratic anymore. When we say we're looking for the solution to a quadratic equation, what do we mean? We're talking about the places where the graph crosses the x-axis. Now, there's three possibilities. It can happen no times, one time, or two times. Here's some graphs of what they look like. So the first option is it has no intercepts. It could be a parabola that opens downward but starts below the x-axis, or opens upward above the x-axis. So those are the two possibilities for a graph that has no intercepts. And you'll find that when you end up with answers that are not real. Right, the next option is it has one intercept, which means it either opens upward and touches the x-axis once, or it actually could open downward and hit the x-axis once and come back down. The third option is that there's two intercepts, right? So whatever the graph does, whether it opens upward or downward, it crosses the axis twice. Those are the only three ways that can happen. You can't have less than 0 intercepts, but you also can't have more than 2 intercepts. How do you solve a quadratic equation? Oh, there's many ways to solve a quadratic equation. One of them is the square root property. You tend to use that when the problems are simple, especially when there's no middle term. So when there's no x term in there, the square root property comes in handy. Completing the square is another option. And the third option is using the quadratic formula. Now, there is another option which we did earlier in the course, which was solving by factoring. Remember when we took the equation, we set it equal to 0, and we factored? So don't forget that that's another option as well. Okay, we just happen to have covered it at a different time in the course, but it still is a good way to solve a quadratic equation. So we'll work right now through square root properties and completing the square, and then later on, we'll get into the quadratic formula. All right, so the square root property simply reminds us that when you take the square root, you allow for the possibility that there's more than one option. So it says if x squared equals a, then x equals plus minus the square root of a. And so if you look at number 1, it says x squared equals 9. So when I take the square root of both sides, I end up with x equals plus minus the square root of 9. So x equals plus minus 3. Now you notice the direction says find all solutions. So there are two numbers that I can square that will give me 9. One of them is 3, right? 3 squared is 9. The other one is negative 3, because negative 3 squared is also 9. Negative 3 times negative 3 gives positive 9. All right, look at number 2. X squared minus 75 equals 0. First thing I'll do is I'll add a 75 to both sides. So I get x squared equals 75. And then take the square root of both sides. When I do that, I put a plus minus in front of my square root of 75. Now, square root of 75 can be simplified. Square root of 25 square root of 3, because 25 times 3 gives me back 75. So I'm going to write my answer as x equals plus minus 5 square root of 3. Okay. This is what's considered an exact value. So this is both exact and simplified. Exact meaning I didn't take a calculator and get a decimal approximation, because 75 is not a perfect square. But yet the square root of 75 is an exact value. But then I went one step further and I simplified it. I pulled out the biggest perfect square I could, and there we are. All right, look at number 3. Number 3 says 3x squared plus 4 is equal to 64. So if I subtract a 4 from both sides, I get 3x squared equals 60. So I'm sort of working my way back towards that x, because that's what I'm trying to solve for. Everything has to be undone. So addition is undone by subtraction, so I subtract off the 4. Now, multiplication is undone by division, so I want to get rid of that 3, divide both sides by 3. I get x squared equals 20. And now I'm at the point where I can take the square root of both sides. When I do that, put a plus minus in front of that. Right. 20 can be broken down, square root of 4, square root of 5. So x equals plus minus 2 root 5. For number 4, it says x minus 5 squared equals 25. All right, so I rewrote the problem on here so we have a little bit more space to work on this. We have a couple of options here. One of them is, remember that property that says if I take the square root of something squared, I get the absolute value? So I can write this as the absolute value of x minus 5 equals square root of 25 is 5, and then set it up as x minus 5 equals 5, and x minus 5 equals negative 5, because what's on the inside could be 5 or it could be negative 5. All right, over here, if I add a 5 to both sides, I get 5 plus 5 is 10. And on the other side, if I add a 5 to both sides, negative 5 plus 5 is 0. So I get x equals 10, x equals 0, which reminds me that it's not always plus minus the same number. You can use these properties to solve for situations like this. All right, the other side would be simply to say, what if I had x minus 5 squared equals 25? I could take the square root of both sides, and when I do that, put that plus minus in front here, and then say x minus 5 equals plus minus 5, and set up two equations, which is exactly what I have here, right? I have x minus 5 equals 5, and I have x minus 5 equals negative 5. So whether you want to think about it in absolute value terms, or doing plus minus the square root of 25, either one works. All right, look at the one underneath it, the 2x squared plus 72 equals 0. If I subtract a 72 from both sides, I end up with 2x squared equals negative 72. Divide both sides by 2, and I get x squared equals negative 36. Now, in this case, I'm not going to end up with a real answer because there's no number that I can square it and get back a negative 36. So at this point, we got to look at the directions. Now, unfortunately, I put the problem up here. My directions were a little vague because they didn't say find all real solutions. It said find all solutions. So if I come up with an x squared equals negative 36, if I take the square root of both sides, the square root of negative 36 is an imaginary number, right? It's, well, square root of 36 is 6, so it becomes plus minus 6i. Right? If I square 6i, I get 36i squared, which is 36 times negative 1, negative 36. So if it says find all solutions, I'll go all the way down and I'll find imaginary solutions. But sometimes the problem will specify find all real solutions. And so if it says find all real solutions, then there's no solution. Right? So there's no real solution. There is a non-real solution, 6i and negative 6i, but there is no real solution to that problem. And I can see the same thing is going to happen in number 6. I'll end up with an x squared equals negative 11, so x equals plus minus I times the square root of 11. Okay? Unless the question said find all real solutions, well then there's no solution to it. All right, so suppose that I drop an object from a height of h feet. Its distance above the ground after a certain number of seconds is given by this formula. Okay, so think about dropping an object from that height. It'll fall down. How far it's above the ground, right? So let's say you're picking this specific spot, is distance above the ground will be given by this formula. So a toy falls 40 feet from a window. How long does it take the toy to hit the ground? So the distance that it travels is going to be 40 minus 16t squared, right? Because it started here 40 feet above the ground and it worked its way down. Now, if the toy falls 40 feet, I know that it fell 40 feet. The question is how long it took to hit the ground. Hitting the ground means that the distance above the ground is 0. So I say 0 equals 40 minus 16t squared. Let's add that 16t squared to both sides. And I get 16t squared equals 40. Divide both sides by 16, and I get t squared equals 40 over 16. Right, to solve it, I take the square root of both sides. Now, normally I would put a plus minus in front of this, except you realize what's going to happen is if I put a minus, it's going to give me a second value over here, which doesn't make sense because that would be where t values are less than 0, right? On this side, the t values are positive. On that side, they're negative. So I would be looking for a negative amount of time. That doesn't make sense, so I'm not going to include it in my problem. Instead, I'll focus on simplifying the square root of 40 over 16. Well, I can break it down into the square root of 40 over the square root of 16. The square root of 40 can be simplified, right? Square root of 4, square root of 10. So 2 square root of 10, that's my numerator. 4 is my denominator. Oh, look, a 2 cancels top and bottom. And I end up with the square root of 10 over 2, and those are in seconds. That's an exact value. If I want a decimal approximation, I can grab my calculator and punch in the square root of 10, and now divide that by 2, gives me 1.58 seconds. So a little more than a second and a half it'll take to hit the ground. So always check the question, right? See whether it says to solve and give an exact value or to solve and give an approximation. So that's one way to do it. That is to use the square root property. That helps when there's no middle term. Another option is to complete the square. So when you complete the square, you actually are completing a physical square, a quadrilateral with 4 congruent sides and 4 right angles. How does it work? Well, here's my expression up here, x squared plus 8x. Suppose I want to complete the square. By completing the square, you turn something like this, x squared plus 8x, into a perfect square trinomial that can be factored. If it can be factored as a perfect square, it can be solved very easily. So suppose I had x squared plus 8x. X squared plus 8x can be written x plus 4x plus 4, but where's the missing piece? X times x is x squared. X times 4 is 4x. 4x times x is also 4x. This is the piece of the square that you don't have. How do you find that piece of the square? 4 times 4 gives you 16. So if this thing were x squared plus 8x plus 16, I would be able to factor it as x plus 4 times x plus 4. And then if there were a number on the other side of the equal sign, then I could just take a square root of both sides, make it an absolute value, and be done with it. So it's literally a part of this big square, x plus 4 times x plus 4, that I'm trying to find. And so if I fill in that missing piece with a 16, I'll have something that's factorable. If you want a process list, I can run through a process list, and then we'll run through a couple examples because I think that might be helpful too. So remember we said the goal is to turn it into x minus a value squared equals another value so that I could then solve easily. In this case, we're not going to set this equal to 0. We're going to pull the x squares and the x's on one side and the constant on the other. If that number before the x squared is not 1, we're going to divide through to make that number before the x squared 1. This third step is the whole key to the process. Take half of b, square it, add it to both sides. So I will say that probably every time I do one of these completing the square problems. Ax squared plus bx equals c. I'm going to look for this term before the x. I'm going to take half of b, square it, and add it to both sides. Once you do that, then it's set up as factored, factor it, and then solve the equation like we have before. All right, this should make some more sense after we go through a couple of these. All right, look at the first one. X squared minus 16x equals 0. First of all, this is already set equal to 0. I don't have a constant term, and so I don't have to move anything over to the other side. A is 1. B is negative 16. So I'm going to take half of negative 16 and square it. Half of negative 16 is negative 8. When I square it, I get 64. So I'm going to add a 64 to this side, but I also have to add a 64 to the other side, because if I only add a 64 to one side, now the equation is not balanced anymore. All right, so I get x squared minus 16x plus 64 equals, and on the other side now, I have a 64. Once I do the completing the square process, this will always factor as a perfect square. You can go back and check. First term squared would be x squared. 2 times the inside would give you negative 16x. Last term squared would give you 64. All right. Take the square root of both sides. That turns this into an absolute value. So the absolute value of x minus 8 is equal to 8. So either x minus 8 is 8, or x minus 8 is negative 8. When you add an 8 to both sides here, you get a 16. When you add an 8 to both sides there, you get a 0. And so this thing has two solutions. Relatively simple example. We move the 64 over to the other side, took the square root of both sides, and solved with an absolute value. All right, let me pull out the board and put this second one on here because there's no way it fits in that little space. All right, the second problem was x squared minus 8x plus 13 equals 0. So this looks more like a little bit more complicated completing the square problem. I want to solve for x. You notice in this case, you might say, well, maybe I can just factor. But this thing is not factorable, right? There's no factors of 13 that add up to negative 8. 13 is prime, so 1 and 13 are your only two options. And they don't add up to 8. So let's try this by completing the square. So the first step is take this 13, move it over to the other side. So I'm going to get x squared minus 8x, a little space, equals negative 13. Remember when you subtract a 13 from both sides, now you get a negative. All right, so how does the completing the square formula go? It says take half of negative 8, right? Negative 8 is the b term, so take half of negative 8 and square it. Negative 8 divided by 2 is negative 4. Negative 4 squared is 16. So take half of b, square it, add it to both sides. When I do that, look what happens. This side over here factors. Now, how does it factor? There goes half of b again, right? Take half of that negative 8. That's what goes in the parentheses. You could also look for factors of 16 that add up to negative 8, and you'll come up with negative 4 and negative 4. On the other side, 16 minus 13 is 3. So right away, I see this is going to look a little bit different from the other problems I've solved, because 3 is not a perfect square. All right, let's carry on. Let's take the square root of both sides. And so the square root of x minus 4 squared is just x minus 4. And on this other side here, I'm going to put my plus minus. Okay, you could do it with the absolute value. I think it's going to be faster to do it this way because look what happens. Now all I have to do is add a 4 to both sides. When I add a 4 to both sides, I get x equals 4 plus minus the square root of 3. And there are actually two solutions sitting in there. One of them is 4 plus the square root of 3. The other one is 4 minus the square root of 3. And you can actually check by going on a graph and graphing that original function and then get decimal approximations. The square root of 3 is about 1.7. And so one of the places it crosses the axis should be 5.7, and the other one should be about 2.3. Okay, so that's how I solve this by completing the square. Half the middle term, square it, add it to both sides, simplify, take square roots. All right, let's see what else was on my list. The next one that was on that PowerPoint was 2x squared minus 5x equals 3. All right, so this one already has the constant brought over to the other side. If it wasn't, like if it was 2x squared minus 5x minus 3, first thing I'd have to do is move that 3 over, but it's already there. Next step then is to look at the number before the x squared. We haven't had one of these before. The number before the x squared is not 1, it's 2. I want to get rid of that. So I'm going to divide everything through by 2. So that I get x squared minus 5 halves x equals 3 halves. Now, buckle up. Fractions are coming. Never mind, fractions are already here. I want to take half the middle term and square it and add it to both sides. So the middle term is negative 5 halves. If I take half of negative 5 halves, I get negative 5 fourths. Okay, so that's half the middle term. Then I want to square it. So if I take negative 5 fourths and square it, I'm going to get 25 on the top, 4 on the bottom. Half the middle term, square it, add it to both sides. So plus 25 fourths here, plus 25 fourths there. Now the good news is the left side factors. They always will. And if we do the completing the square formula correctly, left side will always factor. It'll factor into what? X minus 5 fourths squared. That same 5 fourths that we got here for half of b, that's what gets squared. That's what goes on the inside of that square. All right, on the other side, we're going to need a little help with that 3 halves. Because I got a 25 fourths, and I want to add it to something. Well, 3 halves is the same thing as 6 fourths. And now add things together. So 25 plus 6 is 31. 31 fourths. Ooh. Beautiful set of numbers here. All right, so what do? We take the square root of both sides. Square root of this side over here. Square root of that side over there. I'll put my plus minus so that I get x minus 5 fourths equals plus minus the square root of 31 over the square root of 4. Well, the square root of 4 is 2. So this is really saying the square root of 31 over 2. Let's clean this up a little bit. X minus 5 fourths equals plus minus square root of 31 over 2. There's really 2 problems hiding in here as solutions. One says x minus 5 fourths equals the square root of 31 over 2. The other says x minus 5 fourths equals the negative square root of 31 over 2. And now I just have to add 5 fourths to both sides. Now, how you leave the answer, I guess, depends in part on how the question wants it. I've got 5 fourths plus the square root of 31 over 2. Here, if I add the 5 fourths to both sides, I get 5 fourths minus the square root of 31 over 2. You can leave it like that. You can also multiply top and bottom of that second term by 2 so that you would get, for example, x equals 5 plus 2 square root of 31 all over 4, right? Take that root 31 over 2, hit top and bottom with a 2, and you end up with 2 square root of 31 over 4. So if the question ever asks you to combine it into a single fraction, then that's what you have to do. Otherwise, I think it's okay to leave it the way it is. All right, there was one more example on there, and that's going to be the end of this video because it's getting long. Let's take a look at that last one. Let's see if anything interesting happens. I've got a 6x squared plus 10x plus 2 equals 0. So the first thing is we shove that 2 over to the other side. So I get 6x squared plus 10x equals negative 2. I check before my x squared. Number before the x squared is a 6. Divide everything through then by 6 so that I get a 1 before that x squared. Okay, so I get x squared plus, here's another one with a fraction, 5/3 x equals negative 1/3. Right, simplify 2/6, you get a third. Now, what do we say? Take half the number before the middle term. So take half of 5/3 gives me 5/6. Square it, and I get 25 over 36. Add it to both sides. So add the 25 over 36 here. Add the 25 over 36 there. While we're sitting here, let's look at this side over here. In order to make this work, I'm going to need a common denominator. Clearly 36 will work, right? 25 over 36. What am I going to do with the thirds? I'm going to have to multiply top and bottom by 12, which gives me a minus 12 on the top, 36 on the bottom. Now I can combine them together. 25 minus 12 is 13 over 36. All right, let's factor this side. We said I'll always factor as half of that middle term, so x plus 5, 6 squared. And on the other side, 13 over 36. All right, square roots of both sides. Put my plus minus here. And I end up with x plus 5, 6 equals plus minus the square root of 13 over, well, instead of writing the square root of 36, I'll write 6. And now the last thing to do is to subtract a 5, 6 from both sides. So watch what I'm going to do here. I'm going to write this as x equals negative 5, 6 plus minus the square root of 13 over 6. And now I already got a common denominator. In this case, why not just combine them together? Negative 5 plus minus the square root of 13 over 6. Now, if anybody like on a homework problem ever gives you a couple of boxes and says you got to put one solution in each box, then one box gets negative 5 plus the square root of 13 all over 6. The other one gets negative 5 minus the square root of 13 all over 6. But if you're writing something out in a piece of paper, you can certainly leave it like that, and that'll give me both solutions. And that's starting to look suspiciously like the solution to something done by the quadratic formula. That's coming in the next video.